Hey there, this is episode 6, and we're going to keep going making the shooty bang bang happen in our game. This episode's going to be a big one, so strap in. First, I'm going to make a module called Contracts, and a submodule of that called Weapons. This will be a core module that is referenced all over the codebase, so we want to be sure that the scripts aren't referencing anything else unnecessarily. Specifically, our contracts are intended to be interfaces only, so we can follow the design by contract principle. For our project, I'm going to name it iObjectWeapon. Notice that I'm calling it a weapon and not a gun like the example earlier. I haven't fully decided that I want only guns for this game, and so by naming it weapon, I remind myself that it is intended to allow not just guns, but also melee weapons or any other kind of weapon we might dream up later on in production. Now, we need to ask ourselves, what kinds of functionality should a weapon have? For this project, I want the weapon to have the following functions: on equip, on drop, on attack primary, on attack secondary, and on reload. Notice how we don't have the curly braces and instead we have a semicolon. That's because on interfaces, we don't define the behavior of what each function does. Instead, we define a name and return type, and we let any type that extends from this interface define what that function does, as long as it fits within the parameters we defined here. Now let's talk about why I chose these specific functions. I'm designing the contract from the player's perspective. Specifically, I am focusing on the verbs that the player would understand the weapon in terms of. For example, I am planning on the player having the capability for equipping, dropping, attacking with primary fire, attacking with secondary fire, and reloading. And each weapon can determine what that verb means to it. So for a rifle, secondary fire could just mean aim down sights, or it could launch a grenade from a machine gun like in Half-Life. The player doesn't need to know what happens once they triggered a primary fire, only that it is a verb that they can use to interact with the weapon. Now we are going to play with the player scene again. This time we need to tweak some things. We want the gun to follow the camera, and the easiest way would be to make it a child of the camera. But I'd like to introduce you to the wonderful remote transform node. You can place a single remote transform node anywhere you will like, and it will apply its derived transform to the node you tell it to. This means you could just make a spatial in the root of our player node and use a remote transform to assign the position of this spatial. This makes the scene tree less deep, which can make managing it easier down the line. Now, to choose which node gets assigned the transform, on the remote transform node you have to assign the remote path, and it opens up a dialog so you can choose which node to use. Additionally, you can choose what parts of the transform to pass along. For example, in our case, we don't really care about scale, so we're not going to pass that on. But position and rotation are what matters the most to us. What I will place below the camera is a raycast node. This will be a simple raycast for picking items up. We will do the logic for this in the character controller. So first we need a reference to the raycast under the camera. Then we can use our input event function to check against a button. I'll bind it to interact, which isn't an input action quite yet. Then we can force the raycast to update. This ensures that it isn't lagging behind, even if it's off. By default, the raycast is turned off, and turning it on will have it check every physics step for a hit. This way, we only check when the player is trying to pick something up, saving us a bit of the efficiency. If it hits something, we can get the collider, which is a bit counterintuitive, because the collider actually doesn't give us the collision shape that was collided with, but the physics body that contains that collision shape. This means that if we make the gun object a rigid body, the script needs to be on the rigid body, not on the collision shapes itself. From the collider, we can check if it is an iObject weapon, and if it is, treat it as such. Now if you'll notice, we're using code from a different module. It's in the module contracts.weapons. And so it's going to be up here in our using statements. And so as long as we're looking at the contracts.weapons and not a namespace for this module, we should be fairly decoupled in our information. The way we are going to handle equipping and unequipping weapons is by reparenting. This is where a node is changed where it is in the game. Some interesting and dynamic functionality can be created with this. So we can get the collider from the raycast, and then we can unparent it from its current parent. What this does is ensures that the parent node knows that it doesn't have this child anymore, and can fix some edge case issues. Next, we can add it as a child to that spatial we made earlier. This attaches it to the player because that parent spatial will always be locked to the camera. And first what we're going to want to do is rename that spatial, so it's something a little more intelligent. I'm going to rename it to weapons because this is the node that will hold all of our weapons. Next, we want to reference it in our code and make sure we have a reference to it that we can use later. And if you can notice, I named it weapons root because we're going to treat this as its own micro scene tree, specifically for containing the weapons. And so this node that we're referencing is the root, the single parent of all of the weapon nodes that we currently have on the player. And so now that our node is removed from its original parent, we can add it as a child of our weapons root node, and that will attach it there and let us use it later on in more interesting ways. Because we know that this node is an iObject weapon, we can call the onEquip function so the weapon knows that it was just equipped. The inline casting is very useful when we just want to call a single function, but if we wanted to do multiple functions, I would make a reference to it. Now we can get a reference to our weapons root and check against its child list to see what weapons are equipped and how many are equipped. As of the code right now, there is no limit to how many weapons can be equipped, but those kind of limits would be set in the code. For example, I want to drop the currently held item if we try to pick up a third item, keeping the player at always 2 weapons. And so this line here will print out to the console how many weapons we currently have held every time we press the interact button. And it happens after we equip our weapons, so we know if we picked one up or not. So now the question is, how do we determine which weapon is currently active? There's a few different methods. We could have an index stored and then check the index to get the correct weapon, similar to a hotbar in many other games. Another option would be to reorder the nodes as children of the spatial whenever one is equipped. This would basically treat the inventory similar to a stack, which is a data structure where the most recently referenced elements is on the top, and older elements are at the bottom. It's not perfectly like a stack, because a true stack would only allow operations on the top of the stack, and disallow anything below the top of the stack being interacted with. But now what we can do is when picking up a weapon, we can move it to index 0 on the parent, which makes it the first child. Then we can check if there are more than a certain number of weapons. For this case, I want no more than 2 weapons. Then we can drop weapons at indices over that value until none are left. I prefer to do this as a while loop, just in case there was some kind of overflow. That way players can't glitch the game and have more guns than they're supposed to. Now, when dropping the items, we need to know where to reparent them. For now, we are just going to assume that the player is at the root of the level space, and that it is also a valid space for items to be moved to. In 99% of cases, this will be true. And let's not forget to on-drop the iObject weapon. I'm just moving things around so that we have everything in the proper order. We want to make sure that we're calling our iObject weapon functions at the end of our functions here, because now the child will be guaranteed to be at index 0 when we equip it, and we guarantee that it's already removed from the player's tree and added to the level tree when we call the drop function. My intention for this is that later on we will enable and disable the physics bodies on the guns. Now we need to make a weapons scene. I'll make a simple pistol and I'll speed through making this. And so to make things easy on us, I'm just going to use the Kenny's blaster kit so that we have a bunch of different fun models to play with, and we don't have to worry about modeling and texturing and putting it together. So because of our module approach, we want the resources that a script is going to be using, or that a certain data is going to be using, in that same module. So our weapons models are going to be in a submodule of weapons called models. And as you can see, we have all of these. Some of them are going to give us an X. In the import tab, you can turn off octahedral compression, and that'll usually fix the error in importing. And so now the blasters are named with letters, and so we'll have to see what each of them are. Because these are just treated as scene files, they're actually a GLB, a GLTF binary model file, we can open them directly. If you just hit open anyway, you can view it, but you can't make any changes, which works for us. And so you can see this blaster, it has what looks like a clip. It has some iron sights that we could look down. And it looks maybe like a machine gun, maybe like a different kind of gun. And so we might want to keep looking. See, this one has a stock. It looks a little more heavy, probably packs a lot of recoil. And this one's red. It kind of looks like almost an Outlaw's blaster. I like this one, so I'm going to use Blaster H for our model. Now we need to make the root to be a rigid body. And so because we're using the GLTF models, what you can do is you can go down in the import tab to storage, and we can change from single scene to instant subscenes. And when we re-import, you can see there's Blaster H GLB and Blaster H SCN. This is a binary scene file. PSCN is a text scene file. And so in this one, it's just the model, it's just the mesh instance here. And so what we'll do is on this node here, which is going to be our scene, we can just drag and drop that model there. And now we have the mesh instance. We use the mesh instance to make a tri-mesh collider sibling, and then we make a script on the pistol root node called weapon pistol. And now in the script, we want to inherit from our contract interface iObjectWeapon. Then we will need to implement the methods. For now, that's all that is necessary for this, is to set the local transform to 0 when equipped, and to make sure to disable the rigid body. This makes sure we don't get weird transformations off in the place in the camera's field of view. And in Visual Studio Code, if you hold Control period over something that has the red squiggly line, it can offer some options. And so we can implement the interface or implement all members explicitly. We're going to implement the interface, and what that does is it creates all of those contract functions that we have, and this time it generates them with a throws statement. This creates an error. It'll crash the program if this happens, and so generally you can just delete them, but this is a stub to throw an error is what it is if you try to run this without properly implementing it. And that's why it's called a not implemented exception, because the error isn't that something was broken, it's that we just simply have not implemented it yet. And so now we have those set up so that they will just print out what's happening. So now what this is doing is this taking the property transform from the base class, and we're assigning the origin to 0. And this is the local, not global transform. So it's only where the gun itself is positioned. And then for our transform, we'll assign it to the modified transform, orthonormalized. And so what that does is that helps making sure that repeated modifications to the transform don't cause any weird, unsightly problems. This is usually only necessary if you're making a lot of modifications to a transform, but I want to put it in here just in case. Additionally, it would be nice to disable the physics, and so the way we can do this is by setting the mask and layer for the physics object to 0. Basically, if something is on mask 0 and layer 0, it will not interact with anything. But at first, we're going to want to make sure that we know what it is originally. So we're going to store that when the pistol is added to the scene. And so what this will do is this will store these values, the collision layer and mask, as the OG or original physics layer and physics masks. Specifically, this type is a uint, which is an unsigned 32-bit int. It's specifically unsigned so that it can store more values in it, which is pretty useful when you want to have layers and masking work. Now that those are stored, when we equip, we want to set the collision layer and the collision mask to 0. And when we drop, we want to reset the collision layer and mask to be the original layer and mask. And so what that'll do is when we pick it up, we'll say that we're being equipped, we'll reset the transforms so that it sticks to wherever the parent node is, which we already set to match the camera. The collision layer and mask go to 0, so it will not collide and nothing will collide with it. And then when we drop it, it turns that back on to the original formatting that we have set in the scene. Now if we place a few of these objects in the level, we can go pick them up, and when we pick up too many, we will drop them. And so something we forgot to do, as you can see by the debugger, is we forgot to make the interact input action. Additionally, the raycast of the camera is only going by 1 unit forwards, and we can see that with the debug shape. It's going down by 1 as well, and we want it to go forwards by 1, which is the -1 on the z-axis. We'll make it -5, so we can see the distance there. Remember, enabled will make it update every frame, but we're actually using a force update, so it only checks when the player uses the interact input action. So I'll make interact, and I'll make it the physical key E. I feel this is pretty intuitive for a lot of keyboard players. We can clear that and save. And now let's try it again. And so as you can see, the pistol, weapon pistol on equip, and weapons held is 1. And you can kind of see it on the camera because we didn't move anything off from the camera, so it's actually centered on the camera. But it will move around with the camera, as you can see. And if we can get it right, you can see that another one was called, and now we're holding 2. And we're still holding 2. And so something kind of funky is, where did they go? See, their transform needs to be reset when we drop them. Also, we need to make sure that the position of the weapons holder is somewhere more logical. So we'll have to move that. First things first, we can take our remote transform and we can just move it so that it's forwards from the camera and a little bit down. And then we'll make it a little bit to the side. And so now something else that we want to be sure about is we want to make sure that the model is facing in the negative z-axis. The letters of the axes are on the positive of the axis. And so this is going to show up backwards. And so what we're going to do is we're just going to rotate on the Y by 180. We're going to delete the collision shape and remake it. Make sure to do a simplified convex sibling. And now that should be correct. We can check by adding, we do Control-Shift-A, we can get these. And so we'll do weapon pistol. And as you can see, it gets added exactly as we expect, facing forwards. And if we were to go into the camera and click preview, we can see the gun right there in our perspective. So an easier way to manipulate the transform would just be to assign the whole transform to transform.identity. This will reset the position, rotation, and scale. So if we are changing the scale in the root node of the rigid body, then that'll cause some problems. Fortunately for us, rigid body does not like having a scale applied to it, so it actually isn't going to affect us in any way. What we're going to do is we're actually going to use the character controller to assign the transform. And so when we drop it, we want to assign the global transform to be the global transform of the player. We got to make sure to cast it as a spatial here, because regular nodes don't have a transform, but spatial nodes do. We actually don't have any safeguards here to ensure that this is a spatial, but because of how we're building our weapons, there's no way to interact with it if it isn't a 3D rigid body. Therefore, if it has to be a three-dimensional physics body, it has to be a spatial. And so it's a more implicit safeguard because we can't create the content that would behave this way without implicitly following these guidelines. So now we're going to delete this here and try it out. So as we can see, it follows it around. And if we go and pick up another gun, now we're holding a second gun. Then we can drop another gun. And you can see that they're in the body and then they disappear. So let's see what's happening. We can go into the remote scene tree here, and that's for the currently running game. So we can see weapon pistols 4 and 3 are stored on the player, and 0, 2, 5, and 6 are in the level. And if we want to be a little bit further, we can see that they're falling because the linear velocity is changing. And its position is very, very negative. So what happened is they're actually falling through the floor. Now, this is likely because we enabled the physics while setting them directly inside of the player. And so maybe something a little more useful would be to set them to the position where the gun is held, which we know is outside of the player and a little bit forwards. So you might still be able to drop it outside of the map, and we can make safeguards for that later on. But for now, what this will do is this will let us drop the gun a little bit more intelligently. So we're going to go do that. First, we're going to stop this, and we're going to go do that. So all we need to do is actually just use the weapons route. And as you can see, and sometimes it falls through the floor. And so we can tweak that with a few changes here. Let's make the remote raycast a little bit closer and more up to the camera. We'll add a pistol and make sure it still looks good. And so that looks a lot better. In fact, I might even double the size of this pistol just to make it easier to pick up. So what we're going to do is we're going to go into Blaster H, this is the mesh, and we'll change the scale to be 2 to 2. So that makes it a little bit bigger. Now we need to remake the collision shape by deleting it, going into the mesh, and making the convex sibling. So now if we go back, you can see it's a little bit bigger. It does kind of stick inside of the player, but because the camera's looking from inside of the capsule, you don't see the capsule colliding there. And so it'll collide a little bit with it, which will push it out instead of having it go directly down. And because this is bigger, it'll be easier to pick up because we don't have any way to tell where that raycast is. So as you can see, we currently have this pistol held. It behaves with the light just as expected, and it's in our face. And these are a lot bigger. We can push them around. There, we picked one up. Picked two up. There, we dropped one. Dropped another one. Now, back when we were designing our levels, you might remember that I mentioned about CSG boxes and why they're nice for prototyping, but they're horrible for the final implementation. One of the reasons this is the collisions are pretty inaccurate when you're using CSG. And so generally, if you want to have more accurate collisions, you need to use a physics body. For example, this one is a static body, so it will not move. And then give it a collision shape. I'm using a box shape, and what I did is I set it up to match the floor here. So it might be a little bit above the floor, but for our purposes, that doesn't matter as long as it fixes the collisions problem. And as you can see, there it is. Now, these pistols look really good, but briefly I want to show off materials because we could make them look a little bit differently. So what I'm going to do is we'll go into the models. We have blasterh.scm. And in the model here, we have the mesh and the surface materials. And how Godot imported these is all the materials are actually here in with the model files. They're the .material files. So what I want to do is I want to show in file system. So this is the metal material. I'm going to turn the roughness down a bit. Increase the specular. And you can see it's a little more reflective now. So I think I'm just going to go up to a pure white. And that way it'll be almost a perfect metal here. Now we can see that this is the red, which is the main thing. I kind of want to see if I can make it look a little more plasticky. So I'm going to show in file system. It's the pink material. We'll go into the metallic, and I want to turn the metallic off. And it'll still be very smooth, but not metallic. I think I'll even give it a 25% roughness. Now let's see how that looks in the game. You can kind of see how the different shapes reflect and how it looks in the game. Let's take it a step further. One of the other things we can do to make the effects look a lot more interesting is by adding a world environment. So you can see there's that node there. And we have to make a new environment. This is a special kind of resource built into Godot. And as you can see, it made everything look very bad because there is no background right now. So right now, I want to go to the sky, have a procedural sky. And as you can see, we're basically back to the way things looked before. Now, if we go to screen space reflections, we can enable them. And now if we look at the metallic parts, you can see that a little bit of the surroundings are reflected onto the metal parts. Additionally, screen space ambient occlusion will make edges just a little bit darker. You can also add glow, so that if something's shining, like right here where we're reflecting the sun, it'll reflect a lot more and kind of blur around. You can also change the intensity or the strength. You can also add bloom to just make the whole thing look like a dreamscape. You can see the different kinds of blend modes. The soft light is very soft. Replace is good for debugging. This shows you what parts of it are going to be bloom. You can see there. Screen will make it be a huge blob. And additive will just make everything super bright. And so we could add bloom as well. And now it's suddenly this very bright, very painful to look at dreamscape. I'm going to turn that off. Go back to soft light. Keep all those as they are normally for now. We can also add a tone mapper, so linear is the default. Aces will kind of help make them a little more cartoony, which I think looks really good with Kenny's models. They're all designed to look a little bit cartoony. There's the default aces and aces fitted. Aces fitted looks really good when you have brights or glows. And so now let's see how that looks. See how the metal is kind of reflecting things around it? It kind of looks more grounded. It looks more like a real object as opposed to just something on the screen. And so playing around with the world environment and with different material settings can help you make your game look a little more grounded, even if you're going for a cartoony aesthetic. And it is kind of fun to watch them just kind of sprawl around. And if you look very carefully, you can see that the screen space ambient occlusion is making a dark patch around the gun on the ground. I think we're almost done with this. I think there's only a few more changes we would want to make. The first one being knowing where we're looking. I'm not going to make any kind of crosshairs right now, although Kenny does have another wonderful pack of different crosshairs available. For now, what we're going to do is I'm just going to put a little dot on the screen, and it's going to be as easy as we possibly can have it. So on top of our spatial, we can actually add a control node, which is a root for UI elements. And you can see it switched to the 2D space because everything up here is happening in 3D space. This is happening in 2D space. And so this is a UI node. Of all of the systems I've used, game engines, libraries, what have you, I've even done some website building. Godot is my absolute favorite to build UI in. I actually prefer this to using any system for the web. And that might be controversial. So the base control here, we want this to be a full rect. What that means is it'll scale with the camera size, or on the desktop with the window size. And then what we can do is we can have a centered container. We want that to be a full rect. And what that'll do is it'll put whatever's inside of it centered. So we're going to make an image, or not that, a texture. rect. And what are we going to load in here? We're going to load our icon. Isn't it cute? And so it's centered on the screen. And then in the visibility, we can actually set the modulate to black. And if we look in there, all the details are gone, and now it's just a black circle. Now, you can use any regular texture you want. And so you could download or draw for yourself a little icon or something, but all I need right now is just a little dot to show me where we're looking. And so let's make sure this is working. That is pretty big, but it gets the job done. We know that we're looking at something. Okay, so what we need to make this scale down properly is in our minimum size, we need to set a reasonable size for the minimum. I would say 12 looks pretty good with the size we have. Then we want the default scale and expand. And in our size flags, we want to check shrink center. What that means is it'll shrink down to its center position to be whatever the minimum size is. And so if you forget to set anything here, this will default to 0 and it'll disappear. Now let's try that again. Because what shrink center does is it'll help it be as small as it possibly can based on the minimum size. And so now it's a little nicer to look at. I think that's all we're going to do for this episode. Hopefully you learned a lot of interesting things. This episode was a tough one for me to make. My college classes started recently, and I was foolish enough to double up on math classes, on top of my regular computer science courses. Thank you so much for watching this series. It is no understatement to say that I am so happy to see where this series is going. Anytime I spend working on these videos fills me with just joy and confidence. I'm so excited that my videos are able to help people make cool stuff. So, in honor of this, and selfishly to try to get my YouTube up to 100 subscribers, I'm asking that you use the hashtag LearnWithSquiggles if you're going to post on Twitter about something you're making with my tutorials. I want to see what people are making, and I want to see if my tutorials are helping people make interesting games. Of course, you're always free to just @ me on Twitter if you want me to see it, but I like the idea of having a hashtag that we can call ours. Something community building? Tell your friends or something. I want to give a big shout out to my members who are supporting me financially over on Ko-fi. They get to see all of my videos as soon as I am done editing them, instead of just one each week. If you want to support me and get the awesome benefit of seeing all my videos early, you can become a member for as little as $1. My current supporters are Noel, Miguel, Grebhoon, and Cody R. Thank you all so much for your support. I couldn't do this without y'all.